So we will start with today's lecture. Already in the last lecture, in the last Monday, we have seen what we have seen. We have seen the different what is the importance, then what is the meaning of energy monitoring and targeting, okay, difference, then applications we have seen, okay, and the advantages. And also we have seen the elements, in which 7 elements are required and 5 to 6 elements are optional depending on the industry, which are elements of monitoring and targeting. After that we have seen data and information analysis, okay, in which we can collect the data of different energies consumed like thermal or electrical, etc., okay, and distribution of that energy. And after that we have distributed the energy consumption in percentage, okay. After that we have converted the energy consumption, okay, with respect to the kilocalorie, like electricity consumed in kilowatt hour is converted into calories burnt, okay, by using the conversion factor. So we have seen in this case high speed diesel, HSD, okay, then LPG, electricity, furnace oil, etc. Now today we are going to see the last two topics of this chapter, that is relating energy consumption and production, and then CUSUM, okay, that is cumulative sum. So these are both the techniques, okay, which are required for energy monitoring and targeting. Okay, the ultimate goal is to conserve the energy of a particular industry or plant or a organization. Now we are going to see relating energy consumption and production. So here in this case, this is the concept as its name indicates, okay. So what is the name here? We have to correlate the energy consumption and the production of the industry, okay. This is here. In this case we are going to see what are the different techniques, or how we can represent the data, okay, in a graphical representation way, okay. So first is we have to graph the data, okay. Now there is a critical feature of management and monitoring and targeting of energy, okay, that is to understand what drives the energy, what is the factor that drives the energy consumption, okay, which is responsible for the consumption of energy. So is it production, or number of hours of operation, or weather conditions, okay. So this is the critical feature of monitoring and targeting of energy, which need to be kept in. So after finding out what is the factor which is going to drive the energy consumption, we can start to analyze the data, okay. So from first this point we are going to gather what are the different factors that are going to drive the energy consumption. Then we are going to get some data, okay, in a particular format. Then we can start to analyze the data in order to see how good our energy management is, okay. So now after collection of energy consumption data from this thing, we and after collection of energy cost also and energy production data also, the next stage of monitoring process is to study and analyze the data, okay. Study and analyze the data of what? Data of energy consumption, data of energy cost, then data of production data, okay, or like data of production, okay. And we have to analyze the data in order to understand what is happening, actually happening in our industry, okay. Now we have to analyze the data, means we have to make some calculations for the data, and then we have to represent the data in a readable format or a readable way, okay. Like for example, there are two ways, okay, two different things or methods in order we can display the data. First of all, in terms of table, and second in terms of graphical representation, okay. Table means like this, okay. If you can see here, this table 8.2 fuel conversion data, okay. This is just a visual representation of the data, okay. And second is here in the next figure you can see pie chart. This is a graphical representation of data. So just tell me from both of the type of data, which is easier one to understand or to see or to visualize. Which data is easier, table data or graph data?
Graphical data.
Graphical data is very easier, na? It is very efficient and it has very less iterations. Okay, and we are not required to see the number of columns and number of rows, etc. We just need to see the actual graph or pie chart. Okay, so that is the advantage of having graphical data. Now here, in this case, in order to relate the energy consumption and production, we have to show the data in a graphical format. Okay, the data will be presented graphically. So now a better appreciation of variations is almost always obtained from a visual presentation, okay, rather than a table of numbers. Okay, that I already said. Advantage of visual representation, that is graphical data. Now graphs, okay, graphs means this graphical data. It generally provides an effective means of developing the energy production relationships which explain what's going on in the plant. Okay, now here energy production and energy consumption relationships we are going to see, and we are going to see what's inside the plants. Okay, what are the things which are going inside the plant by gathering this data. Okay, now here firstly we can use the bar chart. Okay, so there are different number of charts or graphical designs or graphs which we can use. First is bar chart, then line chart, okay, then 3D chart, then pie chart, then also we can use scatter plot. If you are using machine learning or regression, you are aware of the fact of scattering plot, then heat map, and so on so on. Okay, there are different types. Okay, so for using, you can also use bar chart. Okay, now you can see here, this bar chart can be obtained from the Excel sheet only. Okay, you just require two columns, and when you select both of the columns and go to insert, and then you can click on the chart or the bar graph, and then you can easily going to get the comparison chart of this. Okay, so now this data, if you can see, this chart is the energy consumption chart. Okay, details for current year and previous year. I'll zoom it. If you can see here, there are two graphs, okay, in a single line. Comparative graph, this is comparative bar chart. Here the blue color indicates the energy consumption in the year 1999, and the parallel green color indicates the information of energy consumption for the year 2000. Okay, so by this we can differentiate the data. Okay, again next is you can also use line chart. Okay, so first of all, in the process of this relating energy consumption and production, we have to gather the energy consumption data. Okay, previous year and current year. Okay, per month data. After that we can also graph the two different data, that is energy consumption data with the production data. Okay, energy consumption with respect to the production. Okay, so you can see here, this is the energy and this is the production graph. So this is a line chart. Okay, so red one indicates the production data and blue one indicates the energy consumed data, and this is the x-axis is of year, the particular month and year. Okay, so it starts from December 99 to December 2000. Okay, next after finding out both the relation between energy and production data, we can we should go through the specific energy consumption, SEC. Okay, which is in terms of kilowatt hour. So you can see here in the x-axis there is a date, okay, per month, like January 99 to December 2000, and on the y-axis we can see this is the specific energy consumption in kilowatt hour. So January 99 च्या टायमाला, okay, you can see 4,80,000 पेक्षा जास्त होता consumption and so on. You can gather the data. So firstly काय करायचं आहे, energy consumption data, then comparison of energy consumption with production, then we have to find out the specific energy consumption data, okay, and the graph, and then we have to find out now combination of both. We have to combine specific energy consumption with the production data. Okay, so now here it is specific energy consumption with the data of production. Okay, you can see y axis on this left hand side is specific energy consumption, on the right hand side it is production data. Okay, now this could be production means number of units produced or number of things developed, etc. So it will be in numbers and this will be in kilowatt hour. Okay, and if you can see on the x-axis there is a month and year. Okay, so there are two different plots. Okay, first one is bar chart and second one is line chart. Okay, line plot. Okay, and lastly, this is the main thing, we can use scatter plot. If you are aware with the machine learning process or regression process, you will be know about what is scatter plot. So scatter plot is nothing but, okay, it is a data representation in terms of points. Okay, okay, so you can see here there are different points and you have to make a line. Okay, you have to by using the machine learning algorithm, by training and testing and splitting the data sets, you can find out a line which is approximately fitting to the curves. Okay, so there are two different concepts like overfitting and underfitting. Okay, there are different concepts. If your machine learning is good, you can go through that. So this is the graph of energy versus production. So now here you can see this should be in kilowatt hour and this should be number of items produced for that particular energy. So for 2 lakh of items produced, the energy consumed is around 1350 and so on. Okay, like somewhat, okay, 1305, sorry, 3500 or 1000, etc, etc. Okay, so this is nothing but the scatter plot. And if you can see here this line, okay, which is the training line, this matches. Okay, and this is quite underfit. Okay, it is not overfit, it is underfit. Okay, so by using different single linear regression, multilinear regression and space vector modulation, we can find out the different datas. And then we can after this energy production, energy versus production graph, we can, one second. hmm. Hmm. So this already we have seen. Now this is the explanation of the previous chart. This chart shows a low degree of scatter indicative of a good fit. Okay, though it is a underfit, we can call it as a good fit. Okay, and we do not need to worry if our data is fit. Okay, so if suppose the data fit is poor, we know there should be a relationship, okay, which indicates a poor level of control and hence potential for energy savings. Okay, so by plotting this kind of data, we can find out the different trends of the energy consumption in a particular industry and with respect to the production. Okay, so here we have a formula here which is important in case of energy consumed for a period. Okay, this formula is important for the next point, that is CUSUM, that is cumulative sum. So just see the formula, energy consumed for the period. Okay, if you have to find the energy consumed for the period, formula is C plus M into production for same period. Okay, now here C and M are two different variables, okay, which indicates C means, so now we will see where M is the energy consumption directly related to the production variable. Okay, so now this M is also energy consumption, C is also energy consumption, but the difference is that this M is the energy consumption which is directly related to production. Okay, so number of production, if it is less then it will be less, if it is more it will be more. And C is nothing but it is a fixed energy consumption. Okay, fixed energy consumption as in the energy consumed for lighting, energy consumed for heating and cooling, and different ancillary services that are not affected by the production value. Okay, so this is important, production for the same. Okay, now hmm, by using this formula we can calculate the expected or standard energy consumption for any level of production, okay, within the range of data set. Okay, now we are going to see the last part of the topic, that is CUSUM. Okay, that is cumulative sum. Now this is nothing but, now CUSUM I think already we have seen in the statistics part in our 10th or in our primary or secondary schooling, or in case of maths 1, maths 2, maths 3, etc. So what is CUSUM in case of energy management or monitoring of energy and targeting of energy? So CUSUM, that is cumulative sum, represents the difference between, so it is the difference between the expected or standard consumption with the actual consumption. Okay, expected or standard consumption with the actual consumption. Now if you are going to see it in the next slide, so suppose the CUSUM works like, I'll show you the diagram of this. Now suppose this is a CUSUM plot. Okay, here this zero line, line 0 is the baseline. Okay, and the CUSUM is nothing but the difference between the actual data consumption, actual energy consumption, and the standard or expected energy consumption. So the energy consumption, if you can see here, it will start from, for example, for the month of January it is showing below 0. Okay, then up to April, okay, it will rise. In the month of April it will be greater than 0. Okay, and in the month of June again it will be less. In the month of September again it will rise, and so on. So the CUSUM value is nothing but this line. Okay, it should oscillate around the value 0. Okay, we are going to see it now. This is nothing but, these are the points which are the CUSUM point. Okay, cumulative sum points, and this is the difference. Okay, suppose below 0 is the actual energy consumption, and above 0 is the expected energy consumption, so it should be revolving around the line 0. Okay, next is so already we have seen the CUSUM represents the difference between the baseline, okay, which is the expected or standard consumption, and the actual consumption points over the baseline period of a time. Now this technique of CUSUM not only provides a trend line, it also calculates energy saving or losses to the date, and it shows when the performance changes. Now here if you can see, whatever you are seeing here, the line, this is the trend. Okay, so in the month of January the energy consumption is less. Okay, as soon as the months are going to increase, time is increasing. In the month of April the consumption is quite little bit higher. In the month of May again it will be less, and this is the trend. Okay, which we can see, and from understanding and analyzing this trend we can save the cost of energy. Okay, so basically it calculates the saving or losses to date. Okay, now here this CUSUM graph follows a trend and shows the random fluctuation of energy consumption, and it should oscillate around 0. As I told earlier, it should oscillate around the 0 line, and this trend will continue until something happens to alter the pattern of consumption. Okay, which will be the effect of energy saving measure, or worsening in energy efficiency, like poor control, housekeeping, or maintenance. Okay, suppose in this case January, February, March months are quite same. Okay, suppose there is, you have in month of April you purchased bigger equipment which consumes a lot of energy, so it will go up. Okay, energy consumption will rise. Again, suppose in the month of May you have purchased energy conservation device like power factor corrector, harmonic analyzer, etc. So in that, after that month, the energy consumption will decline, and so on. This is nothing but the trend which CUSUM plot or graph shows us. Okay, now the CUSUM technique is simple but remarkably powerful statistical method, okay, which highlights some small differences in energy efficiency performance. Okay, and this point, that is the highlighting of small differences, will be seen in the next slide. Okay, so now regular use of this protocol or procedure allows the energy manager to follow plant performance and spot any trends early. Okay, so by just looking at this, okay, we can see the trend and we can predict the trend also for the forthcoming days. Okay, now we are going to see that CUSUM technique. I'll zoom out this. So now here, to perform the CUSUM technique, to find out the CUSUM values data points, what we are going to have, we require first of all the energy consumption data, okay, monthly, then production data monthly. Okay, production might be in what you call it as in terms of weight or in terms of numbers. Okay, so just a second, I'll resume in 2 minutes. hmm. The recording has started. So where was I? The CUSUM technique. For the to obtain the CUSUM data sets, we require two data, that is energy consumption per month, okay, and then production per month, that could be in numbers or in tons of weight. Okay, so now here there is a industry of which we have taken a data. This is a sample data, okay, sample case of industry, in which we have taken the data of 18 months, okay, from January to 18 months, like 1.5 year data we have taken. Data of what? Data of monthly energy use and monthly production. Okay, and what they have said during the month 9. Okay, so in case of this 9 month, a heat recovery system was installed. Okay, so now this heat recovery system is nothing but it absorbs the heat, excess heat, and it is very useful for energy conservation techniques. Okay, so they have installed this heat recovery system in the month of 9. Okay, in ninth month. So they have noted here. We are going to see in the next part. Okay, next slide, what is the use of that. And using the plant monthly data, okay, estimate the savings made with the heat recovering system, the plant data, okay, they have shown here. So from 1 month to 9th month, the energy consumption and the production is with respect to the absence of heat recovery system. So after 9 month, or from the start of the 9 month, the heat recovery system has been installed, and we are going to see what are the changes. So after that installation of the heat recovery system. Okay, now in the next slide, steps what. Now we are going to see what are the different steps to find out the CUSUM analysis. So first of all, we have to plot the energy production graph for the first 9 months. Okay, now here we have already have the data we can plot. So we have to plot the energy versus production data for the first 9 months from 1 to 9. Okay, step 1 completed. Then draw the best fit straight line. Okay, we have to draw the best fit straight line. So now here I'll show you. This is the graph of that energy versus production data. Now here, if you can see the graph, in the dark blue line indicates your actual data points, okay, actual comparison with the energy and production data, and this black line, straight line, is nothing but the training data set, okay, or it is a fitting line, okay, what we can find out by using the linear regression, etc. Okay, So we have to plot the energy production graph, then we have to draw the best fit straight line by using regression techniques, and then we have to derive the equation of line. So as all of you know, in the maths subject, okay, we are going to uh, solve the equation of a line. Okay, we have to find out the equation of the line. So what is the equation of line in a graph? What is the general formula for that?
Y is equal to mx plus c.
Yes, y is equals to mx plus c. That is the equation for equation of line. Okay, from a plot. So basically, what we are doing, we are taking the intersection points, and then we are finding the value of y. Okay, so here in the step number 3, you have to derive the equation of line. Okay, so for this line, for this for sorry for this data, we have a line here, we have a best fitting straight line, and we also have a line equation, that is you can see here, 0.4 p plus 180. This is your mx plus c. Okay, and this is e calculate means y. Okay, so three steps are completed. Okay, and the equation derived is e equals to 0.4 p plus 180. Okay, now step number 4, we have to calculate the expected energy consumption based on the equation. Okay, now here you can see expected energy consumption means we have to use the equation 0.4 p plus 180, and then we have to put the equations value in the equations, and we have to find out the expected energy consumption. Okay, so e calculate, okay, if you can see here, this e calc, okay, is nothing but the expected energy consumption, okay, based on the equation of line. After that, we have to calculate the difference between actual energy consumption and the expected energy consumption. Okay, so this is nothing but the CUSUM. Okay, and after that we have to find out the cumulative sum, actual cumulative sum of the CUSUM points. Okay, so इकडे आपण ई कॅल्क्युलेटर फाइंड केले, देन इथे काय केले, ई सी एल सी मायनस ई ॲक्च्युअल स्टेप नंबर 5 मध्ये. आफ्टर स्टेप नंबर 5 वी हॅव टू कम्प्यूट क्युम्युलेटिव्ह सम. ओके, स्टेप नंबर 6 इज दिस, क्युम्युलेटिव्ह सम्सचे व्हॅल्यूज आपल्याला काढायचे. ओके, त्यानंतर वी हॅव टू प्लॉट द क्यूसम ग्राफ. क्यूसम ग्राफ इथं प्लॉट केले. ओके, ते तुम्हाला दाखवतो मी. आणि त्यानंतर we have to estimate the savings accumulated from the use of heat recovery system. आता हे जे हीट रिकव्हरी सिस्टम आपण यूज केलं आहे, ओके, त्यांनी जे सांगितले डेटामध्ये, हीट रिकव्हरी सिस्टम इन द मंथ ऑफ 9 जे इन्स्टॉल केले, त्यानंतर जे फरक पडले ते आपल्याला स्टेप नंबर 8 मध्ये बघायचं. ओके, सो वी आर गोइंग टू सी स्टेप्स. ओके, so this is the graph, sorry, this is the table for CUSUM. Okay, per month. Okay, so per month energy consumption with respect to the power, production, then expected energy consumption, then difference between expected energy consumption means 332 minus this 340, so it will be plus 8. So this row minus this row will get this row. Okay, these are the CUSUM points. Now here we have to make another column, that is cumulative sum of these points. So now what is cumulative sum? Suppose I'll show you in example. You have to keep plus 8 here as it is for the first row. In the second row, what you have to do, you have to use the I'll show an example. If writing is available, no writing is available. Okay, so in the next line, suppose this is minus 16 the data available. So what will be the data here in this row? So it will be nothing but plus 8 and minus 16. Okay, this will be minus 8. Again for this you have this data plus 16. Okay, already we have find out. So what will be here? Here it will be nothing but minus 8 and plus 16. So it will be plus 8. Again so on. हियर इन दिस केस झिरो कसं आलं, झिरो कसं आलं कोण सांगू शकते? वेन यू आर गोइंग टू फॉलो द स्टेप्स यू आर गोइंग टू गेट झिरो कसं आलं म्हणजे हा 8 आहे तसा हा -8 त्याला ॲड केले, मग 8 - 8 झिरो. मग परत इथं -8 कसं आलं, -8 + 0 -8 and so on. This is nothing but the cumulative sum technique. Okay, and these points are important. Okay, आता हे जे आपण केले, ओके व्हॉट वी हॅव डन इट ऑन द हँड कॅल्क्युलेशन. ओके 2 मिनिटात बघून केले आपण. बट सपोज इफ युअर डेटा इज व्हेरी लॉंग, इट कन्सिस्ट ऑफ मिलियन्स ऑफ रोज, number of columns are very large, so that point you can use Python script or you can use Excel files, Excel sheet for that. Now I have used the Python code in order to find out the cumulative sum. ओके, सो पायथन ज्यांना कोणाला येत असेल त्यांनी एकदा बघा. फक्त पहिलं काय केले, एक एम्प्टी लिस्ट इनिशिएट केल्या. ओके, त्यानंतर इंटिजर दिला n. ओके, आफ्टर दॅट आय हॅव व्हॉट आय हॅव डन, आय हॅव यूज द इनपुट कमांड. ओके, एंटर द नंबर ऑफ एलिमेंट्स, एंटर द एलिमेंट्स असं मी केलं आहे. तर पहिलं माझं काय, नंबर ऑफ एलिमेंट्स किती आहेत, समजा आता माझे हे 18 आहेत. ओके, नंबर ऑफ एलिमेंट्स किती आहेत, 18 आहेत, तर मी लिहिणार 18. ओके, त्यानंतर मी काय केले, एक लूप लावला आहे. ओके, फॉर लूप इन ऑर्डर कुठंपर्यंत 18 झाले की हे नंबर ऑफ एंटर द एलिमेंट्स बंद व्हायला पाहिजे. तर हा लूप त्यासाठी आहे, फॉर एक्स इन रेंज 0 to n, त्यानंतर एलिमेंट्स, त्यानंतर अपेंड केली आहे ती लिस्ट परत. ओके, त्यानंतर कुठलं महत्त्वाचं, टू फाइंड आउट द क्युम्युलेटिव्ह सम लिस्ट. ओके, त्यासाठी एक व्हेरिएबल घेतला आहे जे. त्यानंतर आय हॅव यूज्ड लिस्ट कॉम्प्रिहेन्शन टेक्निक. लिस्ट कॉम्प्रिहेन्शन टेक्निक ज्यांना माहीत असेल ते काय, what is list comprehension? If anyone knows, they can tell me. List comprehension ऐकून माहिती आहे काय, पायथन? Anybody? Okay, no problem, I'll tell you what is list comprehension. आपण जे फॉर लूप वगैरे यूज करतो ना, ते एका त्याला 2 ते 3 हे लागतात इटरेशन्स, किंवा 2 ते 3 लाईन्स लागतात, लाईन्स ऑफ कोड. By using list comprehension and just by putting the values, we can make the for loop of 3 line code into a single line only. सिंगल लाईनमध्ये करू शकते. तर इथं ते इनपुट असते फॉर लूप आणि त्याचं आउटपुट. ओके, दॅट्स इट. देन प्रिंट ओरिजिनल लिस्ट. ओके, ओरिजिनल लिस्ट म्हणजे ते आपण दे देणार आहे. आता समजा हे दिस इज माय ओरिजिनल लिस्ट +8 -16 अप टू 0, and then I am going to print cumulative list. Okay, that is j. Okay, j मध्ये काय असणार आहे, आता माझी जे क्युम्युलेटिव्ह लिस्ट आहे ते असणार आहे फ्रॉम +8 to -50. ओके, सो पायथन तुम्ही यूज करू शकताय, किंवा यू कॅन यूज एक्सेल शीट ऑल्सो. एक्सेल शीटमध्ये पण फॉर्म्युला आहेत काय काय, ॲरोमध्ये पुट करून, इक्वल्स टू पुट करून तुम्ही घालू शकता व्हॅल्यूज. ओके, नाव हां कुठं होतो आपण, हां. So what we have done, we have calculated the CUSUM values. Okay, these values. उसके बाद we have to plot the CUSUM graph. So CUSUM graph is plotted here. Okay, 8.10 जे हे ग्राफ आहे हा CUSUM चा ग्राफ आहे. The 0 is the baseline. Okay, now you can see the trend for the month of January. Okay, the consumption is about 10. Now it will go on decreasing, increasing. So this is the ideal CUSUM graph because it is rotating, or it is standing, oscillating around the baseline. Okay, so now if you can see here, in the month of 9 already they have told, त्यांनी काय सांगितले, हां इथे during month 9 a heat recovery system was installed. Okay, so here if you can see मंथ ऑफ 9 मध्ये, आता इथं ऑलरेडी ट्रेंड कसं दाखवते की एनर्जी कन्झम्पशन कमी आहे. ओके, 9 मंथपर्यंत. मग 9 मंथ सरपास केल्यावर इफ यू कॅन सी हिअर द एनर्जी, आय विल झूम इट आउट. If you can see, after the passing of 9 month, you can see a sudden decline in the energy consumption. Okay, that is because of the effect of that heat recovery system. त्या हीट रिकव्हरी सिस्टीमचा इफेक्ट तिथं दिसते आपल्याला. आणि ते थोडंफार सस्टेन राहतोय आणि परत यू कॅन सी द ट्रेंड इट इज डिक्रीजिंग. ओके, अँड सो ऑन. दिस इज बिकॉज ऑफ द installation of heat recovery system. Okay, this is nothing but the CUSUM plot. Okay, by finding out the different values. Okay, आता हे जे व्हॅल्यू आहेत +8 -8 हे 52 वगैरे हे सगळे हे व्हॅल्यू आहेत क्यूसमचे. ओके, दॅट वी हॅव फाउंड आउट. नाव लास्ट स्टेप. लास्ट स्टेप काय आहे? Estimate the, already we have plotted the CUSUM graph, then we have to estimate the savings accumulated from use of heat recovery system. Okay, we have to show the savings. Now here in the graph I'll zoom it out. If you can see here, it can be seen that the CUSUM graph oscillates around the zero line. Okay, for several months. Okay, then drops sharply after month 11. Okay, 11 month नंतर ते एकदम sharply decrease होते consumption energy चा. This suggests that the heat recovery system took almost 2 months to commission. Okay, heat recovery system जे install केले, it required at least 2 months. Okay, to work in a better manner. Okay, so after 2 months of operation of heat recovery system, we are getting the results. That is, the results are the declining of the energy consumption from the month of 11. Okay, now this suggests that the heat recovery system took almost 2 months to commission and to reach proper operating conditions. Okay, after which steady savings have been achieved. Now if you can see the approximation, total 1.8% or approximately 2% of energy consumption is there. Okay, in the last 7 months after the month of 11, from 11 to 18. Okay, this is nothing but the advantage of CUSUM graph. Here we can see the trends of energy flow, and then here we can see what are the different energy conservation opportunities and what are the different energy efficiency technologies that are implemented. Okay, so I think we are done with the CUSUM and the chapter number 4. So anyone, if you have a doubt, they can ask.